The goals of this video are to be able to identify and name the different sides of a triangle. We're going to look at the special properties when we're looking at similar triangles, that is triangles that are the same shape but just different sizes. And then we're going to look at a way to describe the ratio between the sides in those triangles. If I have an angle like this one here, and I've got this angle in the middle here, I'm going to call it theta. Theta is just a Greek letter that we use to name angles all the time. These two sides here and here, they are adjacent to the angle because they are the arms of the angle, they are touching it. But this third side over here, if I connect it into a triangle, is not touching the angle at all. That makes this side here the opposite side. If I had this triangle here, I could name all the angles in this triangle as A, B, and C. Depending on which angle you're looking at will change which side of the triangle is opposite. So if I was looking at the angle A, the side opposite that angle would be this one over here. If I was looking at the angle B, the side opposite that one would be this one over here. And if I was looking at angle C, the side opposite that one would be the one over here. Now, in a right angle triangle, we have a special side called the hypotenuse. The hypotenuse is the side that is opposite the right angle. It's not opposite any other angle, it's specifically the one opposite the right angle. So if we were looking for the hypotenuse in the triangle, we look for the right angle and we go opposite from that one. Now, if I was in this triangle and I was looking at, say, this angle down here in the corner, that would make the side over here opposite that side. And if we wanted to name the final side in the triangle, the name we would give it is the adjacent side. Now, technically both the adjacent and the hypotenuse are adjacent to the angle, but the hypotenuse has a special name, so we name that one first. These two triangles are the exact same shape. One of them is just triple the size of the other one. But what we can do is we can write down what the ratio between the sides are. So if I was to look at the ratio between the opposite side and the hypotenuse side in the smaller triangle, I would do the opposite side, which is 3, over the hypotenuse, which is 5. And what we should find is that that is the exact same as the ratio between the opposite and the hypotenuse in the larger triangle, which is 9 over 15. And sure enough, they are the exact same thing. They both equal 0.6 if you were to write it as a decimal. Now, if I was to do the ratio between the adjacent and the hypotenuse, I would be doing the ratio between 4 and 5 for the small triangle, again, because 4 is the adjacent side and 5 is the hypotenuse. And I would be doing the ratio of 12 and 15 in the large triangle. Again, both of these equal the exact same thing. They both equal 0.8. Now, lastly, if I was to do the ratio between the opposite side and the adjacent side, on the small triangle, that would be between 3 and 4, and on the large triangle, it would be between 9 and 12. Both of these equal the exact same number, 0.75. Now, what we would like to do, because we use these ratios all the time, between the opposite and the hypotenuse, the adjacent hypotenuse and the opposite adjacent, we'd like to give a name to each of these. So, the name that we decided on was sine for the opposite and hypotenuse ratio, cosine for the adjacent hypotenuse ratio, and tangent for the opposite and adjacent ratio. Now, we rarely call them by their full name, so instead we use the exact same names as are on the calculator, which is sine, cos, and tan. We use those instead. So what we end up doing, we cut the names off, so it's just the first 3 letters. The sine of theta, now theta is the angle that we're looking at in here. Sine of that angle equals 3 over 5. Cosine of that angle is 4 over 5. And tan of that angle is 3 over 4. If that angle changes, the ratio changes, but if the angle stays the same, no matter how big the triangle is, the ratio will always equal those same numbers. That is what the trigonometric ratios are all about. If you're asked to find the sine, cosine, or tangent of an angle in a triangle, you're going to need to remember which ratio goes with which of those names. So we have this mnemonic called SOHCAHTOA. What this does is it lets you know which sides and in which order go with which ratio. So for this one here, I have SOH. That stands for sine, opposite, and hypotenuse. So when I am trying to find the sine of alpha, I'm going to do the opposite side to alpha, which is 5, over the hypotenuse of the triangle, which is 13. If I was asked, however, to do the sine of beta, I'm still going to do the opposite over the hypotenuse, but the opposite side is now 12, not 5, because I'm going opposite this angle instead. So I'm going to do 12 over 13 instead if I'm doing the sine of beta. If I was asked to do the cos of alpha, I would do cosine of the adjacent over the hypotenuse. So I'm going to do 12 over 13 for cos of alpha, because 12 is the adjacent side, 13 is the hypotenuse if I'm looking at the angle alpha. If I wanted to do the cosine of beta, I would be doing 5 over 13, because 5 is the adjacent side to beta. Notice how the hypotenuse never changes. If I want to do the tan of alpha, opposite over adjacent, because tan is TOA, opposite and adjacent. So it's going to be 5 over 12, and tan of beta is going to be 12 over 5, again because you're looking from the opposite side of the triangle.